Hello class, we're on lesson number 4. We're going to do more subtraction and more addition of fractions. And as we read here on page 520 in chapter number 11, the 19th century English poet Alfred Tennyson once wrote, "Every minute dies a man, every minute one is born." Now, when Charles Babbage, a mathematician at the time, read these words, he wrote to Tennyson saying, if this were true, the world's population would remain constant. In fact, however, it was increasing. So, with tongue-in-cheek, Babbage suggested that the lines be corrected to read, "Every minute dies a man, and one and a sixth is born." Now, although this sounds strange and not very poetic, it does make sense. If we write the number 1 and 1/6. Notice I use the word 1 and 1/6. Oop, I'm sorry, we need to get our marker here. Let's get the white marker, and let's just make it a little thicker. So we have 1 and 1/6, and it can also be written as a fraction of 7/6. Okay, so it means that for every 6 people that die, 7 are born, because we can write 1 as 6/6, and we can write 1 and 1/6. That will be 6/6 plus 1/6. That will be 7/6. So that means that for every 6 people over here, 7 die, or 7 are born. For 6 people that die, 7 are born. Now we can look below at this particular illustration, and we can see that the time in minutes, we have 6 minutes running across the board. Now you can see that these segments are smaller in births, okay, because there's 7 of them within the time frame of 6 minutes, whereas in deaths there are 6. So you have a larger value, okay, because we can see that there's 6 versus 7 that are put into the same time frame here. Now, when we write a number such as 1 and 1/6, we do not mean 1 times 1/6, but rather 1 plus 1/6. So we have to be very careful there, especially since we have been getting used to writing things such as, we can write 1/2 x, let's say. And we're multiplying here. We write 2x. We put something next to it. In this case, when we're writing something next to it, it's not being multiplied. It's really 1 and 1/6. So be very careful with that with your fractions. A number written as the sum of an integer and a fraction is called a mixed number. So, because 1 is equal to 6/6, 1 plus 1/6 is 6/6 plus 1/6, which is 7/6. This method can be applied to expressing the sum or difference of any integer as a fraction. Now, first, the integer is written as a fraction, having the same denominator as the given fraction. Then the 2 fractions are added. So we have here 4 and 3/5. What do? They take 4 and 3/5. So we're going to say that's equal to 4 plus 3/5, right? Now, what is 4 in terms of fifths? Now, well, they put 4/1 first, just to show you that you can write 4 as a fraction. And then we can change this expression. By multiplying both the numerator and denominator by 5, we can say that 4/1 is 20/5. And we know that 20 divided by 5 is equal to 4. And we're still adding the 3/5. Oop, ran out of room here. 3/5. So what happens? We can add the 20 and the 3 together, and we end up with 23/5. Okay? By reasoning in the same way that we have in this example, we can express the sum or the difference of any polynomial and a fraction as a single fraction. So let's take a look over here at example number 2. I'll clear the board up, and we'll move along. Get my pen back here, and let's take a look. We have x minus 1/x. So now that looks a bit complicated, doesn't it? But remember, what are we trying to achieve? We're trying to get a common denominator. And if we're trying to get a common denominator, we know we have that tool of 1, the number 1. We can multiply anything by number 1. So we make sure that that denominator is part of that 1. And let me explain what I mean by that. We know that we have here, this is equal to x over 1. Okay, so we express x as a fraction of x over 1 minus 1 over x. Now remember, what we did is that we tried to get a common denominator. So that common denominator would come in the form of x if we multiplied this by x over x, right? So let's do that. So we have x over 1 times x over x. Now can we do that? Well, certainly, because x over x is equal to 1. And we're going to subtract this again by 1 over x. So what happens? Well, let me just go downward here and just say x times x is going to give me x squared. 1 times x is going to give me x. And I have minus 1 over x, which means I can now simply put x squared minus 1 over x. Okay? So we were actually able to express, or this as a fraction, write it as a fraction, that x minus 1 over x. You might say, well, there's already a fraction, but it's not a fraction. Right now, you're just expressing this as two terms, really being subtracted. It's not a fraction all to itself. Okay, and certainly don't do this. Okay, certainly don't say, well, I'm going to express this as a fraction. I'm just going to put this over 1. No, that's not what we're looking for. Okay, though technically that might be the answer, it's really not what we're trying to teach you here. So let's take a look at example number 3. It's a little more complicated, and we're going to really start putting more math tools to use here. Clear up my board and get my pencil back. And so what do we have? We have x plus 2, and we're going to add 1 over x plus 1. Okay, so we need a common denominator, and for us to have a common denominator, we have to look at what we have here. We can see that we actually have, I mean, this gets a little bit tricky. You might think of these as 3 terms, and we certainly can, but you know, we can actually just put a 1 here. Okay, we can divide this by 1, and that would be the same. Okay, I can prove that by saying, well, what if x were 3? Okay, then it would have 3 plus 2 over 1 would be 5. And if I would have just put x over 1 and x over 1, I would have had 3 over 1, and 2 over 1, again, is simply 5. So it's the same expression. So let's do that first. Let's go ahead and express this x plus 2 over 1 plus 1 over x plus 1. Okay, so you can see we're expanding. We're not just using a simple variable. We have a binomial. And yes, we'll end up introducing polynomials, much more complicated. But let's take the first step. So we've written this as x plus 2 over 1. So now what we want to do is take the common denominator, which is now going to be, it isn't, but we're going to create it by taking x minus 2. Now I'm going to put parentheses around it because I'm going to multiply it, I'm sorry, x minus 2 over 1 times x plus 1 over x plus 1, right? And what's x plus 1 over x plus 1? It's equal to 1, all right? And again, let's just add over here our 1 over x plus 1. Now you might say, well, why aren't we changing this one? Well, because this is a 1, okay, all we need to do is change this factor into that factor. Similar to the one that we had with number 4 and the number 2, okay, when we were doing that example in the previous chapter, or previous lesson, excuse me. So let's go ahead and do our math here. Now it obviously gets a lot more complex. What are we going to have? Well, we're going to have to multiply this out, and we'll use our FOIL method maybe and say, well, I have x times x, right, would be x squared. Okay. And I am sorry, this is a plus. I don't know why I put a minus there. Okay, so x plus 2. So first, then we have the outer. Okay, so I'll put plus x. And then I have the inner plus 2x. And then I have the last would be plus 2. And then this is all going to be over x plus 1, right? And on this side, I still have 1 over x plus 1. All right? Now, for the sake of simplicity, we're going to need to add all of our like terms, being that we have over here where we have like denominators, we can go ahead and just add all of these together. And I'm going to go in this direction now. I'm running out of vertical room. I'd like to go vertically down, but let's go ahead and express this as x squared. Let's add. I have x plus 2x, so that's 3x, right? And then I have a 2, and I'm going to add that 2 to the 1. Again, we have common denominator. So what do I have? 2 plus 1 is going to be equal to 3. And then I'm going to express this all over x plus 1. Okay? So that is our answer when we write x plus 2 plus 1 over x plus 1 as a fraction. And we've done that. We've expressed this up here, all of this, as one fraction. I was going to say one simple fraction, but obviously it's not that simple, is it? Okay. Now, we can see that this procedure can also be reversed. Just take a look at our simple example number 4. Write 8 minus x over 4 as the difference of an integer and a fraction. Well, all we have to do is take that 4 and put it below the 8 and put it below the 4. So we end up with 8/4 minus x over 4, and we know that 8 divided by 4 is 2, so it's going to be 2 minus x over 4, which is, again, it's the reverse. See, we would take that and we wanted to express it as a fraction. Now we're going to do the reverse, and we're going to express it as the difference of an integer, which is 2, and a fraction, which is x minus 4. So we have x over 4. So we have 2 minus x over 4. Okay, so that's the end of this lesson.